In this video, we're going to look at how to find sides of right-angled triangles. So you'll recall we had those three ratios. Sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. Okay, so let's make that A a little bit clearer. So the first thing we've got to do in these questions is work out which ratio we're actually dealing with. Then we substitute in the values, and we isolate what we're trying to find, and we do it in our calculator. It's sort of 4 steps. So I'm going to start by deciding which ratio to use. Let's write down what we've got. So here, A is the opposite of 35, so it's the opposite, OPP for short. 6 there is the hypotenuse, being the longest side. And of course, 35 degrees is our theta. So we're looking for a rule that involves opposite hypotenuse and theta. And the rule that we're after there is sine. It's the one that involves opposite and hypotenuse. So now I've decided which rule. I'm now going to write down the rule ready to use. Sine theta equals opposite over hypotenuse. Then I put in the values. So sine theta is 35 degrees equals the opposite, which is A, over the hypotenuse, which is 6. Okay. Now, to get A by itself, remember back to equations, we have to multiply both sides by 6. So what we end up with, if we do that, is 6 times sine 35 degrees equals A. Times both sides by 6, of course. If you times both sides by 6, those 6's disappear. Times the other side by 6. Okay, and we're left with A equals 6 times sine 35. So then you go to your calculator. 6 times sine, S-I-N, 35 degrees. Okay, and we get 3.44 as our answer. Okay, so A equals 3.44 centimetres. We always look to see if that's a reasonable answer, and because it must be less than the hypotenuse, and it is. So there we go. That's fine. All right. So next one, we've got another situation here, and we need to write down what we've got. So F is our unknown, and F this time is our adjacent. We've got 0.346. That's our longest side. That's our hypotenuse. And 32 degrees is our theta. All right, which rule? We've got adjacent, hypotenuse, and theta. So we're going to use cosine this time. Let's write the rule down. Cosine theta equals adjacent over hypotenuse. So cosine 32 degrees equals adjacent, which is F, over the hypotenuse, which is 0.346. Once again, to get F by itself, we times both sides by 0.346. So it's going to be 0.346 times cosine 32 equals F. Let's put that in the calculator. 0.346 times cosine 32, and we get 0.293 to 3 decimal places. So F equals 0.293 centimetres. So there we go. There's our second example. All right. There is another scenario though, because if you look at the previous questions, you notice that what we've been trying to find here is on the top of the fraction. Okay? The A there and the F there is on top of the fraction. Sometimes, though, what you're trying to find is on the bottom of the fraction. And here's a classic example. So let's write down, in fact, what we might do. No, it's right. We need to identify the ratio we're using. So we've got 120 metres and that is the opposite, because it's opposite the angle 5 degrees. We've got capital P there, which is the adjacent. So in this one, we haven't actually got the hypotenuse. It's not involved. And our theta is 5 degrees. I should have done that the other way around, beg your pardon. So 5 degrees equals our theta. So we're looking here, we've got opposite, adjacent, and theta. So if I just go back to the previous slide. Here, the one that's involving those ratios, opposite and adjacent is tan. Tan theta equals opposite over adjacent. Okay, so let's look at that. Tan theta equals opposite over adjacent. All right, so tan of 5 degrees equals 120 over P. Now, you'll notice, and I'll point this out again, in my previous two examples, our unknown thing was on the top and we multiplied the two things. The shortcut I'm going to show you here is that when the unknown is on the bottom, you actually swap those places. So the next line would be the P would go over here and you go 120 over tan 5 degrees. If the unknown is on the bottom, you divide. If the unknown is on the top, you multiply. So now we go 120 divided by tan 5, and we get 1,371.61. So P equals 1,371.61 meters. Now, you might think that's a big answer compared to 120, but remember that angle there is very small, only 5 degrees. It's not drawn to scale. So if you only go to 5 degrees, there's going to be a long length here compared to the height there. So the gradient, if you like, is only 5 degrees. So that looks about right. That would be quite a big number to have a very small angle like 5 degrees. All right, so there's a bit of an introduction there to finding sides. Just repeating, if the unknown is on the bottom, divide the length by the trig ratio. If the unknown is on the top, multiply. Okay, 0.346 multiplied by cosine 32. That's all for now.